Hello everyone, so on this video I'm going to go over a couple of examples on sample space, and for this one we want to identify the sample space in the following situations and state how many outcomes are possible. So the first thing that I want to go over is that a sample space pretty much means find all the possibilities out there. So what are like all the different outcomes that can come out of a situation? So you're considering absolutely everything. And basically in a sample space we're just like writing a list or listing out all these possibilities. So for the first one, we have the following spinner is spun. Here I'm gonna assume that it's only being spun once, right? We're not gonna do more than one spin. So let's go ahead and see what are the possibilities that we can get as outcomes for this spinner, right? So I usually write S for sample space, and then we do a curvy bracket to write down all the possible outcomes that we can get. So I'm seeing that we have 2A's, so we have 1A, 2A's. Notice how even though it's the same letter, because A shows up twice on the spinner, then you have to write both A's, right? Even though they're the same letter, it will be kind of like the same result. There's still like two different A's right there. So we need to write down both of them on the sample space. Then we have a B, we have C, we have an E, and another E, and then an F. So we have 1, 2, 3, 4, 5, 6, 7, 8 different outcomes, right? So we're gonna put the number of elements in the sample space. We can put n of s equals 8. So again, this is 8 outcomes in the sample space. Now we also have on exercise B, it says a 6-sided dice is rolled and a coin flipped. So we have a 6-sided dice that we're rolling, and then we have a coin that is flipped. The first thing I'm going to do is I'm going to go ahead and write the outcomes separately for each one. So for the dice, we have the number 1, 2, 3, 4, 5, and 6. And then for the coin, we only have heads or tails, right? Only 2 outcomes that are possible to get from the coin. Now, when we are putting them together, so this situation, it's kind of like mixing both of them, right? So what do you get in the die, and then what do you get in the coin? So our sample space for the entire situation will be, I'm going to use a parentheses, and I'm going to create pairs. So these pairs are composed of the options and outcomes that we have for the dice and the outcomes that we have for the coin. So for instance, maybe in the coin we got heads, and then for the dice we got 1. Or maybe we got heads and then a 2. Or maybe we got heads and 3. Or heads and 4. Or heads and a 5. Or maybe heads and a 6. So this is assuming that we got heads for the coin, right? Notice how we did change the values and the outcomes for the dice, but we kept the heads, right, for the coins. Now, let's say that instead of a heads, we got tails. And then it's the same thing happening, right? So it could be tails and 2, tails and 3, tails and 4, a tails and 5, or a tails and 6. So this right here, it's covering every single value and every single possibility, for the dice and the coin as they are being either rolled or flipped together, right? Now let's see how many options do we have. How many outcomes is this? So it's 1, 2, 3, 4, 5, 6 for heads, 6 for tails. So we will end up having 12 different outcomes. So we have 12 outcomes in total. Okay. Now, the next one is a little bit different. This one says that we have a bag that contains 3 blue marbles, 2 red marbles, and 4 green marbles. And you're drawing 1 marble out of the bag. So what will be the sample space for this situation? So we have S equals curvy bracket, and then I see that I have 3 blue marbles. Now, I don't know if these marbles are the same shade of blue, right? We're not gonna go ahead and only write 1 blue. We're gonna go ahead and include all 3 of them because these are different marbles. Even though they're the same color, they're different. So I'm gonna have blue, blue, and blue. So 3 blues. We have 2 reds, so RR for red, and 4 green marbles. So green, 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 and green. So our different number of outcomes, so the number of in the sample space is 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 9. There's 9 different elements in the sample space for this particular situation. That means that there is a total number of 9 marbles inside of the bag.